In this video, I'm going to show you how you can install SlimOpenOrca Mistral 7B. I'll be using Google Colab for this demo, but you can use the same command on any Linux instance. You can even install this on Windows if you're using Git Bash or Windows Shell for Linux. This SlimOpenOrca Mistral 7B is the merge of OpenOrca Mistral 7B SlimOrca and Mistral 7B OpenOrca, and this has been created by Pulsar AI. And Pulsar AI is quite known for their NLP models, natural language processing model, and ML tools, which include a lot of toolkits, algorithm libraries, and utilities. Plus, they have few um, quite well-known data sets. One of their data set, Turkish alpaca, is quite well known, and then they also provide some of the tutorials on their Hugging Face page, which you can go through. I will drop the link of all of these models and stuff on in the video's description so that you can follow along. For this demo, I'm going to use, as usual, the blog's GPTQ version of this Slim OpenOrca, which is around, I guess, 4 gig of size. Now let's get started. So I already have created my Google Colab and I have connected my GPU. This is free, so you can create your own Google account and then log in with your Google account. Plus, you can change your runtime here by selecting T4 GPU. And Google is quite generous to offer us this for free at the moment. Okay, so now let's start by installing some of the prerequisites. First of the prerequisite with these transformer based models is to install the transformers library. Let me install it. Let's wait for it to finish and then we will proceed with the next prerequisite. Shouldn't take too long. So you can see that the transformers install is in progress. It is right now git cloning and then checking the branch and resolving it. Let's wait for it to finish. Transformers is installed. In the next step, let's install another prerequisite Optima. Let me run this. Let's wait for it to finish. Optimum is installed, and if you don't know what Optimum is simply an extension of this Transformers library from Hugging Face. And there are two main objectives of this. One is to optimize the running and operations of large language models. Plus, they also provide you a way to integrate third-party tools with Optimum. Okay, now as we are using quantized version for this demo, so first step we need to do is to git clone the auto GPTQ. So let me clone it, and then we need to cd to this directory, so which would be cd auto GPTQ. That's done. Now let's check out the stable version of this repo. This keep changing, so make sure that when if you are running it after a few months, then it is the latest one, and you can check it from their GitHub. So that is done, and now let's install all the prerequisites or requirements within this directory and put exclamation mark here, and let's run it. And it takes around 2 minutes with on this T4 GPU. So let's wait for it to finish. Auto GPTQ is done. Now in the next step, let's specify our model. So you can see that I'm importing some of the libraries for transformers such as auto model for causal LM, which is imperative for our autoregressive models, and then auto tokenizer, which specifies the tokenizer, and then the pipeline to output the model's response when we reach that stage. So first step, we are importing these libraries and then we are specifying the model which we are going to use. So let's run it. That is done. And now let's download our model and then create a tokenizer around it. So this is how I'm going to download my model with the function which we imported above. Let's run it. And then as we saw earlier, it is around 4 gig of size. So let's wait for it to download. Shouldn't take too long. It is being downloaded, which is great. The speed is quite good today. So while it downloads, let me quickly show you what Mistral 7B is if you're not aware. So this is Mistral 7B. It is the best 7B model to date, and I have done a lot of videos around it. You can search it on my channel. It is really a very good model. It outperforms Llama 2 13B on all benchmarks. It also outperforms Llama 1 34B on many benchmarks. And then it uses grouped query attention GQA for faster inference, and it also uses sliding window attention. If you don't know what these are, I have detailed videos on my channel about it. So pretty cool model, I would say. Really like it. And you can see model has been downloaded, and also it has downloaded the config. Cool. Now let's specify our prompts. So this model requires the prompt in this template. So we need a system message and we need a prompt. For system message, which is for our model, and we are just telling a model that I am an AI assistant, and then in the prompt I'm going to ask it this question: what is the capital of Australia? Let me also put a question mark here, and this is a prompt template. These two variables will replace their values here in this prompt template. Then we are sending it uh, to this tokenizer, which is going to create tokens around it, and then we will output the answer. So let's run it. Shouldn't take too long. Let's wait for it to come back. So it has returned us the response, and you can see that the response is pretty cool, spot on. And then it has given us some more information like official currency is this, and main cities are this, and then a lot of other information about Australia here, which seems quite correct to me. Nice. Another thing you can do is that you can even use this pipeline for it. So same thing, we are passing tokenizer and stuff, and let me run it to see if this works with the pipeline. Let's wait for it to come back. So you can see that even in the pipeline, it has provided me quite a good answer, which is cool. Let's remove this and go back to our previous one. Let me give it a bit different and sort of a hard prompt where it has to think a bit. So let me replace this prompt with this one. So you can see I'm asking it that you are an expert at bathroom renovation. So maybe I can make it a system message like this. And then I'm asking it, renovate the following old bathroom. I have a 25-year-old house with an old bathroom. I want to renovate it completely. Think about it step by step and give me steps to renovate the bathroom. Also give me cost of every step in Australian dollars. Okay, so seems good. I'll remove the spaces and let me run it. Let's see what happens now. Let's wait for it to come back. It has returned with a response. So scroll down a bit and you can see that this is the response it has returned. Sure, I can help you with the step-by-step process to renovate your old bathroom. And then it just repeated what I told him or her or model. And then it is these are the steps: planning, design, and the estimated cost here. And then also a bit more cost, and then demolition, then plumbing, electrical, flooring, wall, bathroom fixture, and then it goes on and on because we have restricted the output. So um, this is amazing, I believe. You can see that how cool is that in terms of not only reasoning but also thinking, and the response is quite good too. And look at the size; it's just a quantized version where most of the weights are frozen. So amazing, unbelievable. So very impressed by this model, by this Pulsar AI. I believe that you should try it out if you are interested in this Mistral's variant. I'm quite impressed by the way. And I hope that you enjoyed it. If you have any feedback or questions, please put it in the comments. And if you like the content, please consider subscribing to the channel. Thank you very much.